Welcome to our discussion of a simple example that will help us illustrate the importance of decomposing existentially quantified sentences first. Let's consider the following sentence. Suppose someone said, for all x, f of x, and there is an x such that not f of x. So for example, if f of x was the predicate x is friendly, this would be someone saying everyone is friendly and someone is not friendly. Now, as soon as you hear that, it should feel as though what we've got here is a contradiction. If this sentence is a contradiction, there should be no interpretation on which it is true, and so this truth tree should close. So let's just work out this truth tree and watch how it closes. So for our second line here, since the first line is a truth functional compound, we might simply decompose using the conjunction decomposition rule. For line number 2, we write the first conjunct, and for line number 3, we write the second conjunct. And that comes from 1 by conjunction decomposition, and we check that line off. Now, here we have a choice. We can either decompose the sentence on line number 2 or the sentence on line number 3. And our rule, which is a kind of rule of thumb, is to always decompose the sentences that are existentially quantified first. Let's do that and see what happens, and then we'll come back and actually follow the other way of decomposing it. So on line number 4 then, I would simply check off line number 3 and write not f of a, and I can instantiate to the constant a because a does not appear anywhere yet on the branch, and that comes from line 3 by existential decomposition. Now, when I look at my tree and evaluate what I have, I see that I have a universally quantified sentence on line 2 that says that for any x, f of x. And if that's true for any x, it's going to be true for a. And so I can actually instantiate that sentence to a and write down f of a as line number 5 from line number 2 by universal decomposition, and of course the tree closes. And this seems perfectly reasonable because if someone says that everyone is friendly and someone is not friendly, then that means that there's some person A, we don't know who it is, who is both friendly and not friendly, and that can't possibly be correct. So this shows us that there does not exist an interpretation on which the sentence at the top of the tree is true. All right, very good. Now let's try to do this exact same truth tree, but by following a different order in the way which we decompose the sentences. So we're going to start again with for all x, f of x, and there is an x such that not f of x, and treat that as our set member. And as our second and third step, we have no choice because on line 1, the main logical operator is this ampersand. So here, of course, we're going to write for all x, f of x on line 2 from 1 by conjunction decomposition. And then we're going to write there is an x not f of x from 1 by conjunction decomposition. Now suppose that instead of having followed our rule of thumb and decomposing line 3 first, which is the existentially quantified sentence, we had decomposed line 2 first. What would have happened then? Well, to decompose line 2, we would instantiate to some constant or other. Now it doesn't matter which constant we instantiate to, so we might as well begin at the beginning of the alphabet. So we might have written down fa, and that would come from 2 by universal the quantifier decomposition. Now we still have to deal with line 3 because that sentence is not decomposed, so we cannot judge that we have a completed open branch because we have a sentence that is not decomposed. When we go to instantiate line 3, however, we notice that there does already appear a constant on the branch, and so we have to instantiate to a different constant. So on line number 5, I can write down not f, and now I cannot write down a. I need a different constant, and the convention is to follow the alphabetical order, so I might write down not fb. And that comes from line 3 by existential quantifier decomposition. Now if I just stop here, it looks as if I've got an open tree, and that means that somehow my tree has given me the wrong answer, but of course that's incorrect because we're not allowed to conclude that we have a completed open branch unless we have instantiated all universally quantified sentences that appear in our tree to all the constants that appear on a given branch. And so here, I cannot judge that this is a completed open branch because line number 2 has not yet been instantiated to B. And when we do that, of course, you'll notice quickly what happens. We write down FB as coming from line 2 by universal quantifier decomposition, and of course the tree closes. So we get the same answer as of course we should have. But the difference is that we've saved ourselves a step. So if we compare these two trees here now, the one we did originally and the one we just completed, the only difference is that it took us an extra step here to reach the conclusion that we have a completed open branch.